do many-to-many. For instance, this enrollment here that creates a relationship between the student and the section, we would like to be able to relate them somehow, right? Now, in relational databases, there's only one way that this can be implemented, right? There's only one implementation. You need a mapping table. You need a table that has two foreign keys that reference the original records. And so you can then create the association saying that, hey, that record over there is associated to that other record over there, right? And if you want to reestablish and recreate that relationship in memory, you'd have to join them together, right? So you can see which one related to which. In Mongo and in Java, there's actually multiple ways that you can represent that same type of relationship, right? One way is to use the legacy or the standard way, right? Using foreign keys, right? Now I mentioned earlier that Mongo doesn't support foreign keys, right? What I meant is that it doesn't support referential integrity, right? You can have a value that is equal to some other value in some other collection, and you could just say, well, I want to find, if I know the value in one of the collections, I can use that value to find all the records or the other documents in some other collection with that value. That's basically what join is. When join says, well, here's a foreign key or primary key, and I know the value. Let me go find all the other ones whose primary key or foreign key are equal to the one that I'm looking for. Right? That's what a join is. The only thing that you get from relational databases is this extra set of rules about referential integrity, right? And that primary keys and foreign keys are in this special relationship between each other, right? Not that just the values are the same, is that they have these rules that you can't delete one without the other, right? You can't set one without setting the other one. There's a whole bunch of things, plus cascade deletes and all these other things about triggers that can trigger all sorts of behaviors. Right? None of that here. Okay, but nevertheless, you can fake it. You can say in the enrollment collection, I can have an enrollment collection. I could have a field in there called section, right? And the value of that section, right, could be the value of some other record, right, of some other document who has a primary key equal to section 1.id, right? And same thing for student. For some particular enrollment document, could have a field called student, whose value is actually the primary key of some student that lives in some other collection. Yes, this is exactly what foreign keys and primary keys are, right? The values of some foreign keys are equal to the values of some primary keys in some other record. Yes, right. So basically, we are doing the mapping strategy, the mapping strategy that we can already do in a relational database. Yes? Okay. So we can still do that. Mongo allows you to do that, right? If you wanted to go that route. But Mongo has another option, has a completely different option. The other option is that there is no enrollment. There is no enrollment table. Okay? Instead, you have students and sections knowing about each other. Right? If you think about it, even when you capture this in UML, you might capture it this way. You would have students, you might have sections, right, related to one another, and say that there's a many-to-many relationship, and that's it. Call it a day. You're done, right? Now, if you're going to implement this in a relational database, this is not enough. Right? You need to say, well, there's no way. What does that mean? Meaning I have a field here that has multiple values, that has many foreign keys that tell me which students are enrolled in this. I'm sorry, which sections is this student enrolled in? There is no such thing. I can't have a field in the students that has many foreign keys. I can only have one foreign key. Right? I can have a field that is a foreign key, but I can't have a field that has many foreign keys. Right? There's no such thing. Same thing on this side, right? I can't have a field that has many foreign keys to all the students that are enrolled in this section. There's no such thing in relational databases. So the only way is to have a mapping table, an enrollment table that has that has one foreign key referencing records. One record here is referenced to this one record over there, plus this one is referencing multiple over here, right? And then these would be all separate records. Yes, that's the only way that you can implement this in relational databases. But this being JSON, we don't have that restriction in JSON, right? Because we do have an array. We can have multiple foreign keys, right? So just like we captured it in UML, we can literally implement it just like we captured in UML, right? I can have a field of all the sections that this student is enrolled in, and the section here could have an array of all the students that are enrolled in that section, right? So you could have, student 1, that section is equal, and then the array of all the foreign keys, of all the primary keys, of all the sections that this student is enrolled in. Same thing for the sections. So this is a bidirectional relationship, right? Where you can have the sections knowing about all the students enrolled in that section. Make sense? Now, graphically, right? This is how you would capture it if you use the mapping strategy, right? You would have a mapping enrollment in the middle, referencing the different records, or you instead, and this is the implementation. You would say, DB enrollment insert. So, for instance, we can do that. Oops. Let's do that. For instance, we have here. These are the students. So we have John and Jane, and we have let's see, db.section.find. These are all the sections, right? So we want to create an enrollment. We can say db.enrollment.insert, and here we can establish that the student we're going to enroll John. And the section, so John is going to be enrolled in this particular section. All right, so if we do the DB enrollment find, it says that, yes, there's an enrollment. That student is enrolled in that section. And that's fine. Right? That is certainly an alternative. This is the classical implementation. Right? We have a mapping table referring to 2 records. You could still do it in MongoDB. What you don't get is the referential integrity, the validation that those students even exist, or those sections actually exist. Right? You don't get that for free, right? Which you do in a relational database. Okay? All that validation would have to occur at the application level. So that's the first alternative. The second alternative is that now you can have each student knowing about the sections that they belong to. Right? So, for instance, student 1 knows that he's enrolled in section 1, and student 3 knows that they are enrolled in section 3 and 4. See that? But notice that this needs to be consistent. So that means that it needs to look the same way. It doesn't matter which way you look at it, right? If student 3 says that, student 1 says that they're enrolled in student 1, well, student 1 better exist on the other side, right? If you look at it from the section's point of view, right? So if you look at it from the other point of view, each section knows which students is enrolled in the section, right? So this can become a nightmare. Right? Because what if you enroll a student, right? You need to tell the student, hey, you are enrolled in this section, and you need to tell the section, hey, this student is enrolled in your section. You need to make 2 updates, which usually is not a good practice, right? That whenever you do an update in a database, normally you only want to do a single operation. It's a very common thing, right? Whenever you have 2 operations involved, you always run into the risk of inconsistency, where maybe you remember to do one but not the other, right? And you run into inconsistency where the student knows that they're enrolled but the section doesn't, right? Or there might be some crash or some network hiccup where one of them happens but not the other, and so now you need to enroll transactions. You know, you have to. It just complicates things matter, right? So if you can avoid maintaining both sides, the better, right? Or somehow automate it where it happens automatically, that you don't have to maintain it, right? And there's certainly options to do that where this can happen automatically for you. So yeah, so the alternative would have been to in the student, right? So for instance, we can say take the student here. Where are the students? Students. There we go. We have the students. Pretty. And here we have these sections. Where's the sections? Section. There's the section. What we could do is tell the student, John, that they are enrolled in section 1 over here. Right. So we could say db.user. We want to update. We want to update. John has this username. Oops. And the update that I want to do is I want to create an array. I want to create an array. Okay, that was not there originally, right? Just like I can add new fields like we did with type, just like we did with Office and GPA. Here I'm going to create a brand new field as well. And the field's going to be called sections. So from the student's point of view, they're going to have a field called sections whose value is going to be an array. An array of all the IDs of all the sections that this student is enrolled in. Right? So I can say, the update is I'm going to set a field called sections whose value is going to be an array of the sections that they're enrolled in. So they're enrolled in this section, and they're enrolled in this other section. Okay, and if we update and look at the students again, notice that now we have John has a sections field, right, that has an array of all the IDs of the sections that John belongs to. Make sense? Right? But notice that there's an inconsistency now, right? Because the student knows that they are enrolled in those two sections, but the sections don't know that the students are enrolled in the sections, right? So now I've made a lot of work for myself, right? Having to maintain two representations of the same thing. Notice that the information is identical, right? It's just that it can be navigated in two different ways. So again, if you can avoid it at all costs, right? Because you have to maintain. Ideally, you would only have to maintain one-to-many, as opposed to many-to-many. It becomes much more complex. So let's look at one-to-many.